Question: how do the spinning motors in a fan, these spinning toys, and electric cars even work? And how do you make them? Well, the answer are DC motors. DC motors like this one, and even this one which I made all use a little bit of electricity to make the armature spin really, really fast. And they do this by using the properties of electromagnetism. Simple intuition behind these motors is by using the properties of magnets. We all know that like poles repel and different poles attract. And that is basically the idea we are using to make this motor spin around. Imagine attaching a bar magnet to a stick that allows it to freely spin around. Let's put two magnets on opposite ends like this. The ends of the spinning magnet would be attracted to the opposite poles of the stationary ones. Okay, great. So we made the magnet spin. If we want to continue this, we can do this by swapping the stationary magnets like this. Now the ends will repel each other and be attracted to the other magnet. We can continue swapping these and the magnet would spin indefinitely. Notice how the same thing would apply if we were to swap the poles of the spinning magnet instead. Instead of using permanent magnets like these, we can instead use temporary magnets or electromagnets. Temporary magnets, as the name suggests, are only magnets temporarily whenever we want them to be, unlike permanent magnets that will always be magnetic and we can't turn off. Electromagnets are created when we flow electricity in a coil, ideally around an iron core. This works because of Faraday's law of induction, which showed that electricity and magnetism are connected to one another. Electric current produces a magnetic field, and a magnetic field can generate electricity. Using the right-hand rule, we can determine the poles of this electromagnet. Imagine wrapping your right hand around the electromagnet with the fingers flowing in the direction of the current. Sticking your thumb out will tell you the north end of that magnet. This is the intuition behind a DC motor. We'll get more into how they play a role in helping make the magnet spin. DC motors have three main parts: stator or stationary magnets. These can be either a permanent or temporary magnet, an armature, which is the spinning magnet, this will almost always be an electromagnet, and a commutator, which will be important for swapping the poles of the armature. For my example, both the stationary magnets and the armature are electromagnets. In my example right here, the blue copper wired is the armature, the brown copper wires are the stationary magnets, and then this copper ring right here represents the commutator. Following the current right here, this wraps around this iron nail in a clockwise pattern, which would make this top half south poled. The current then flows out of this wire to the commutator, where it connects to this half of the armature, making this half also south poled. This half of the armature has the wire wrapped in an opposite direction on the other half, making this half north poled. The wire then connects to the other half of the commutator, where it connects to the stationary magnet, making this stationary magnet north poled at the top, where the electricity can flow out and complete the circuit. Arguably the most important part of the DC motor is a commutator. This is what allows the armature to change polarities once it reaches the stationary magnets so that it could rotate continuously. In my example right here, the commutator are these two halves from a copper ring. The polarities of the electromagnet in this position are shown here, and looking from the top down, this would mean that the armature would spin in a counterclockwise rotation. When the ends of the armature face the stationary magnets, the polarity of them will now change. This is because the commutator is made up of two halves that do not touch. So, when the armature is in this position right here, the brushes will pass over the gap and be in contact with the other commutator half. This way, the armature's polarities will now be switched. These are the basic principles on how DC motors generally work. So let's see how you can make one of your own. The first step I did was to make the frame. I cut out measured pieces of wood and then nailed them together. Next, I made the axle. I cut cylindrical wood to the right length and drilled a hole for the armature to go through the axle. For the armature, I used an iron screw and a bolt at the end. I nailed the top and bottom of the axle so it could spin freely, and I cut a copper ring in half and used those to be my two halves of the commutator. To attach the axle to the frame, I put acorn bolts on the top and bottom of the frame. This helps reduce friction when the armature is rotating. If you want, you can use ball bearings instead if you prefer. For the stationary or stator magnets, I drilled large iron screws on the two ends. You have to make sure to measure correctly here. They should be far apart as to not touch the armature when it's spinning, but they should be as close as possible to it to have maximum efficiency. The final step is to do the coiling. The stator magnet should be coiled in the same direction and have the attachment strands where the electricity can flow through. They should also have strands or brushes that contact the commutator but aren't stuck to it. The coiling on the armature should be done with one piece of wire rather than two separate ones for each half. For the coiling, the more is better. It doesn't matter about the thickness of the wire, just the amount of coils in a region. If you keep adding more coils, you'll start getting diminishing returns, however. For the stator magnets, add as much as you would like, and for the armature, you want to find the right balance. Too many coils will weigh it down, while too little won't make the attraction force strong enough. In total, the project costs around $50. Putting it all together and running electricity through it, you should get a result something like this.
No. You have to, that's what I was explaining to this one. Ask Hitchell when the brushes have to be over the gap, because I just explained it to him.
So basically,